Okay, guys, you've watched the video, hopefully the first video for February the 9th, which was on use substitution, and you've worked those problems using use substitution. All right, you've got to be able to do use substitution. Now, this video is going to show you how you can avoid use substitution a lot of the time, but you can't always avoid it. And I'll show you an example in this video of when it cannot be avoided. So I need you to get used to doing it. So if you had trouble, you need to go work some more. So you can work some more or send me an email and we can do a one-on-one Zoom, but you've got to be able to use substitution so that when you have to, when there's no other way to work it, you're able to use it and do it. Okay. Now use substitution is a little bit of trouble, so I tend to avoid it when I can. All right. Now the other thing, before you start watching this video, on Moodle, there is a integration formula sheet, okay, up at the top, kind of around where the homework is, all right? So find where it says MAT 122 integration formula sheet and you need to print that out because you're going to need it next to you when you're watching the video, because I'm going to use it as I kind of go through the examples and make sure you understand which rule I'm using. All right, so if you haven't done that, then stop the video, go print that formula sheet and have it next to you and then start the video again. All right, hopefully you've got that formula sheet next to you and you're ready to take notes. And like last time, you need to pause the video and write down examples or pause the video and write steps. So basically you have your notes just like you'd have them in class, okay? So I'm gonna try to do the same thing, hopefully. I'm gonna share a PowerPoint with you and talk you through the PowerPoint. All right. Now, here's the formula sheet that should be next to you. Okay, so this was on Moodle, so hopefully it's printed off because I can't keep flipping back and forth. All right, so print it off and have it next to you before you go to any of the slides. Okay, so I'm gonna kind of talk you through a few things here while you're looking at your formula sheet. So this is the first one we ever went over. When you're just integrating dx, you just get x, and then of course you got plus c. Now, if you were integrating dz, you would get z. If you were integrating dy, you would get y. So this variable of integration is telling you what your variable is there. All right. The second rule is nothing new. It says when you're adding things or subtracting them, so there does need to be a little minus right there. All right, so make sure that you put a little minus under yours. So it's plus or minus here and plus or minus here. That just means it works for addition or subtraction. And that just tells you, remember, that you can separate them when they're at pluses and minuses, you can separate them and do them separately. Okay? This one's the one that just says if you've got a constant and you want to pull it in front, you can. Now, you don't have to, but you can. Later in the semester, sometimes you'll leave it because you want it there, and sometimes you'll pull it because you don't want it. All right? So you have to decide. Now, this number 4 is going to be a new rule that we're about to go over in just a minute. This number 5 is going to be a new rule we're going to go over. And then 7 all the way down to 16 is going to be a little bit new. We're going to go over those. Okay? Now, that helps us avoid the use substitution rule. So number 4 all the way down to the bottom is going to help us avoid use substitution a lot of the time. So I want you to notice, this doesn't say you have a letter to a power. Number 4 on your sheet says you have a whole expression to a power, like the ones you had before, all right, that you did use substitution on. All right, so we're going to talk about that in just a second on this next slide. All right, number 5 is when you have a number raised to a letter. All right, and the special case is the most common number is going to be e. And that's going to be a little quicker than if you had like 2 raised to a power or 11 raised to a power. We're going to go over 6. We're going to go over this rule all by itself on Thursday. All right, now notice, these are all the ones that you've got memorized. When you integrate sine, you get negative cosine. When you integrate cosine, you get sine. All right, now, we're not going to go over all of these right this second. Okay, we're going to go over some more of these, but basically I want you to notice this. When you have an angle right next to it, you're going to have the derivative of the angle. That's what's new. All right, before when you were integrating something like sine of x, okay, you were really doing this. All right, and here's why. On this problem, your angle is just x. Well, what's the derivative of that angle? What's the derivative of x? Well, see, the derivative of x is just 1. So you had the derivative of your angle, it just wasn't showing. And so your answer would be a negative cosine of that same angle. So you got negative cosine x for the answer. Okay. So when we do one in a minute, you'll see what I'm talking about. But basically, we're going to go over number 7, and we're going to go over number 8. And then we're going to jump down here and go over number 13 and number 14. And then we're going to jump down here and go over 15 and 16. All right. We're not going to go over 9 through 12 yet. These are the ones that you've got memorized: the integration of sine angle, cosine angle, secant squared x, cosine squared x, secant x, tangent x. Those are the ones that you already have memorized. The only difference is now your angle can be something besides just x. So have this sheet beside you, so when we get to this first example, we know what to do. All right, let me show you what I'm talking about. All right, look at this problem right here. All right, here's what the extended power rule says. When you've got a whole expression raised to a power, to work the problem, you have to have the derivative of this inside to work it. And when you do, you get the original function, you raise the power by 1 and divide by that power. Now think about why that's what you've really been doing. When you've been integrating like x, I'm going to put it in a parenthesis to emphasize something. When you've been integrating something like x to the third dx, all right, do you see that this x right here is like your f of x? You got something to a power. Well, according to this rule, you need the derivative of just the inside. But what's the derivative of x? Well, see, the derivative of x is 1. And so, you know, you've always had a 1 there, it just wasn't showing. So according to this, you take what's in your original, so that's your x, you raise it to a power, so you add 1, so 3 plus 1 would be 4. And then you divide by that same 4. And then you had your plus c. Okay. So this 1 right here didn't show up down here. So it's just your power rule, only now, instead of having a single letter to a power, you can have a whole expression to a power. But the key is to work the problem without use substitution, you have to have the derivative of the inside next to it. But notice that derivative does not show up in the answer. And here's why. Think about in Cal 1. If you had x to the 4th, what was your derivative? Didn't that power come down and you had 4x cubed? Well, see, this is part of the derivative, but it's not part of the original. Okay? So look right here. Here's what I'm talking about. So note, you must have the derivative of the inside to work the problem, but that derivative of the inside is not part of the answer. So look what I've got. I've got a whole expression raised to a power. So do you understand that this inside part is my f of x? Okay, that's my whole function. So that 2x plus 3 is this f of x part right here. Okay, so that 2x plus 3 is that f of x right there. Okay, now look what I have to have next to it. I have to have the derivative of the inside. All right, so I have to have the derivative of the inside. So what is the derivative of this inside? What's the derivative of that f of x? In the derivative of that inside, just a 2, because the derivative of 2x is a 2, and the derivative of 3 is 0, and 2 plus 0 is just 2. So to work the problem without u substitution, next to this, I have to have the 2. But I just can't go multiplying something by 2 because I want to. All right. So what can I multiply by that doesn't change something? The only thing I can multiply by and not change something is a 1. So do you understand that 2 times 1/2 is just a strange way of writing 1? So I can't just multiply by 2 unless I also multiply by 1/2, because I can multiply by 1 and not change it. Now, here's what we're talking about. I need the 2 to work the problem, but I don't need the 1/2. I just had to take the 1/2 in order to get the 2 that I needed. But remember our rule. All right, remember number 3 on your sheet says if you've got a number, you can pull it out front if you don't want it. Well, see, I don't want this 1/2. It's in the way. So I'm going to pull the 1/2 out front. But I do want that 2. I need that number. So that's what I meant the whole semester by you have the option of pulling numbers out, but you don't have to. I don't want to pull the 2 out. I need it. I just need to pull the 1/2 out that I don't need. So look what I've got. I've got f of x to a power, and this 2 right here is just the derivative of the inside. So that 2 is that derivative of the inside. So look what it says my answer is. It's my f of x. So I've got my 2x plus 3. Then I add 1 to my power. So 12 plus 1 is 13. Then I have to divide by that 13. And then, I have to keep the number in front. So I get 2x plus 3 to the 13th over 26 plus c. Now that's one of the ones we worked in the last video using u substitution. So if you can use u substitution, but if you don't want to use u substitution, when you have a whole expression to a power, you have to have the derivative of the inside in order to work it. So if you're missing it, as long as what you're missing is a number, you can always multiply by a number and it's reciprocal at the same time. All right, let's go try another one. Okay. All right, these are a couple more that we worked last time. Okay, so look at this one. Again, we don't have anything to do with roots, so I changed roots to powers. Now, I want you to notice something. Do you see that I have a whole expression raised to a power? So according to rule number, let's see what it is, number 4, if I have a whole expression raised to a power, this right here, this inside, I have to have the derivative of that inside to work it. So that inside is my f of x. Well, what's the derivative of this f of x? It'd be 12x, wouldn't it? So I need a 12x. Now notice, I already have the x, all I'm missing is the 12. So if that were 12x instead of x, I'd be ready, I'd be good to go. Well, I can't just multiply by 12 unless I also multiply by 1/12. So what I'm going to do is leave what I need and pull out what I don't need. So this 1/12 is just causing trouble. So I'm going to take that 1/12 and I'm going to move it in front. So I moved it in front. So that still left me this thing to the 1/2, and then 12 times x is my 12x. So look what I've got. This is my f of x, and this right here is my f prime of x. So I've got something to a power and the derivative of the something. So according to rule number 4, if I've got an f of x to a power and next to it I've got f prime of x, I just have my original and I add 1 to the power. So when you add 1 to 1/2, you get 3/2. And then what's the same thing as dividing by 3/2? Multiplying by 2/3. Now notice this derivative does not show up in the answer. It's just got to be there in order to work it, because this 12x is part of the derivative, but it's not part of the original. Okay. All right. Remember Cal 1. All right. So then I just simplified 2 over 36 is 1/18, this to the 3/2 plus c. And again, this is example 4 from the last video that I worked with u substitution. So this is a way to avoid u substitution using what your book calls the extended power rule. Okay. So this thing right here, this rule number 4 on your paper, That rule number 4 is called your extended power rule. So you can have a whole expression to a number rather than just having a single variable to a number. All right, so look at this one right here. Same thing. This is example 5 from the first video. I'm going to work it without u substitution. I'm still going to bring that up, and I have an expression raised to a power. So do you understand that this inside is my f of x? All right. All right, so that inside is my f of x. So right next to it, I'm going to have the derivative of that inside. Well, what's the derivative of this thing? In the derivative of this thing, 4x cubed. Well, notice you've already got the x cubed, so all you're missing is the 4. But I can't multiply by 4 unless I also multiply by 1/4. Now, I just went ahead and put the part out front that I did not need, because like up here, when I don't need it, I just keep pulling it out front anyway. So if you want to write it together and then on the next step, pull out what you don't need, do that. I just tend to write down what I need that's a number and go ahead and pull out at the beginning what I didn't need. So do you understand that this 4x cubed is just the derivative of the inside? So this thing just has to be there to work the problem, but it does not show up in the answer. The answer just says that you have f of x and you add 1 to your power and divide by that number, end. But I have to keep the 1/4 in the front. So like before, you know, positive times a negative is a negative, and that's a 1/4 that kind of got cut off. And I just moved this to the bottom, made a positive 1 out of it. So I get the same answer I got on that first video, but I did not use u substitution. Okay, let's go look at some more. All right, here's another rule number 5 on this sheet. So I'm gonna go back up here at rule number 5. Now I want you to notice rule number 5 is when you have a number raised to a variable expression. Okay, a number raised to a variable expression. Now, on your sheet, you can see it a little better than you can see it here. You have to have the derivative of that power in order to work the problem. All right, so come down and look at it. Rule number 5 on the sheet says this. When you have a number raised to a letter, then in order to work the problem without u substitution, you have to have the derivative of this power next to it. So look what I've got. I've got 3 raised to the 2x. So that's rule number 5 on the sheet. I've got a number to a letter. So according to this rule, I have to have the derivative of this power. Okay, well, what's the derivative of 2x? Well, the derivative of 2x is 2. And as long as it's just a number, I'm good. I multiply by that number and it's reciprocal, because 2 times 1/2 is really a weird way of writing 1. So I need the 2 and I don't need the 1/2. So I took that 1/2 and I pulled it out front. So here's my 3 to the 2x. There's the 2 that I need next to it. All right. So I don't need this d. I don't need 2 dx's. That's just extra. Okay. So according to my rule, if I have a letter, a number to a letter, and have the derivative of that power, say I have a number to a variable and there's the derivative, then I just get 2 things. I get 1 over the natural log of that number. See, that a is that number. So that's why I've got 1 over the natural log of 3. So right here is where I'm using the rule. That 1/2 has to come down because it was in front of my integration. So that's my 1 over the natural log of a times, and then it says, look what it says. It says a to the f of x, the original a to the f of x. So I copy down 3 to the 2x and then plus c. So this is just an irrational number. So I just get this times this plus c. Now, the one that's going to be the easiest is going to be if you had an e. See, if that had been an e to the 2x, it would have been easier. That's the special case on that rule number 5 on your paper. Okay, and we're going to talk about that one in a minute, because that's still this rule. It's still a number to a letter, and I've still got to have the derivative of this next to it. what's going to be easy is this beginning part's going to go away, because if you have 1 over the natural log of that number, the natural log of e is just a 1, so that whole thing becomes a 1. All right, let me show you one and we'll work it real quick. All right, look at this one. All right, here's your rule. This is your special case of rule number 5. Okay, if your number happens to be e, you don't have to put 1 over the natural log of e, because 1 over the natural log of e is just 1. And 1 times e to an f of x is just e to the f of x. So this, notice it says special case on number 5 on your sheet. So when you have e to a power, you need the derivative of the power next to it. Now again, you've been doing that the whole time. Think about it. When you had e to a power, when you had e to the x before, all right, what was the derivative of your power? Well, see, the derivative of your power was just 1. And so you get back e to your power, e to the x. Well, now it's not a 1. Okay, so when you've got e to a power, you have to have the derivative of the power next to it. So what's the derivative of 5x? 5. So I've got to have a 5 next to it. But I can't multiply by 5 unless I also multiply by 1/5. So I need the 5 and I don't need the 1/5. So I'm going to pull the 1/5 out that I don't need. So now it fits my rule. All right, do you see that I have e to a power, and now I have the derivative of the power next to it. So according to the rule, let's get e to the power back, e to the 5x back. And that 1/5 is in front, so it's got to come down. Now, here's what I mean about the derivatives that you already know. You know how to integrate sine just x. But what happens when your angle's not x? Well, when your angle's not x, then you have to have the derivative of that angle next to it if you don't want to use u substitution. So I need the derivative of this angle. So what's the derivative of 6x? Well, it's 6. But I can't multiply by 6 unless I also multiply by 1/6. So I pulled the 1/6 out that I didn't need. So that left me the sine of 6x and this 6. So this is sine of an angle, and this right here is the derivative of my angle. So according to my rule, I get a negative cotangent of that same, a negative cosine of that same angle. So a negative cosine of that same angle, 6x. And that 1/6 is in front, so I have to bring it. So with trig, the only new thing that you have to remember is you have to have the derivative of the angle next to it. The only new thing about e is you have to have the derivative of the power next to it. And the only new thing about your power rule is you have to have the derivative of the inside. So that's what's new on rule number 4, rule number 5, and then all those trig ones down there. You have to have the derivative of the angle. Now, let me show you what I mean a minute ago. Sometimes you still can't avoid u substitution. This is one we worked in the last video. So if we change the root to a power, look what it says. I've got something to a power. So if I want to use rule number 4, I need the derivative of the inside. Well, what's the derivative of the inside? Well, the derivative of the inside is a 2. Well, that's no trouble. I can multiply by 2 and I can multiply by 1/2. So what's the problem? Well, here's the problem. I got this extra x. And what am I going to do with it? See, I can't pull it out front. You can't pull variables out. You can only pull numbers out. So it's not that I can't get the derivative of the inside. It's just I've got extra junk that I can't do anything with. So sometimes when you've got an expression, you can't get away and do u substitution. It just doesn't work. Okay, so this is the only way to work this one is the way we did on the last video with u substitution, because I can't get rid of that x. I can get the 2 that I need, but I can't get rid of this x legitimately. Okay, Now, let me tell you why I like not using U substitution unless I have to. Okay? Let me kind of compare something. It becomes really important when you've got definite integrals. And here's why. If you change to U's here, your A and your B have to turn into U's. Now, I'm going to work this problem without U substitution, and then I'm going to work it with U substitution. Do you understand down here that I have, and there should be a 3 right there, okay? So I have something raised to a power. So I'm at rule number 4. So if you've got something to a power, you have to have the derivative of the inside next to it, okay? And I lost my dx too, so I'm not doing very good notation there. So what's the derivative of this inside? Well, the derivative of the inside is a 3. Well, if I multiply by 3, I've also got to multiply by 1/3. Okay, so I need the 3, so I wrote it there. I didn't need the 1/3, so I pulled it out front. So I have something to a power, and I have the derivative of the inside next to it. So the integration says that my thing stays the way my original f of x stays f of x. My power goes up by 1, and I divide by that same power. But the 1/3's got to come down. And my numbers are 0 and 4. So I plugged 4 in. 3 times 4 plus 2 to the 4th. Then I plugged 0 in, 3 times 0 plus 2 to the 4th. Now what I did was I just said 1. I went ahead and did that 3 times that 4 and put that 1/12 in front. And then I finished up, I did that number minus 2 to the 4th minus 16, and I had to do a 12th of 38,400, which came out to be 3,200. Now, look how much longer it would be if I use U substitution. I would do the same thing. Remember, you can let U be the inside. So U would be my 3x plus 2. So that turns into a U to the 3rd. Now, I've still got to remember to substitute for this dx. So the differential of U would be that derivative 3 times dx. So when I solve for dx, I can put du over 3 in place of dx. So that's what I did. Instead of that dx, I put du over 3. Now here's my problem though. I can't leave it 0 and 4. Because if this is dx, those are x numbers. If I go to u's, these have to be u numbers. Well, how do you know what they are? It's got to follow this rule. U is always any x number multiplied by 3 plus 2. So x is 0. So if I put 0 in there, 3 times 0 plus 2 is 2. So when x is 0, u is 2. So if x is 0 down here, u had to be 2. I can't just leave it a 4 because a 4 was an x number and I need a u number. So I had to plug 4 in for x. So 3 times 4 plus 2 is 14. So when x is 4, u is 14. So when x is 4, u is 14. So if you do U substitution, these A and B numbers have to change, and they become different A and B numbers using your U substitution. Then it's easy to do this part. That's just U to the 4th divided by 4. But now I plug in a 14 to the 4th, and I plug in a 2. I just did that 1/12 in front again, and I still get 3,200. So the advantage of not using U substitution is I don't like changing my A and my B. It seems a little more trouble to do that. But some people want to use U substitution all the time. I'm never going to tell you on a test to use it or not use it. You can decide. But there's going to be a few times like this one back up here that everybody's going to have to use U substitution. So you'll see Dr. Gann avoid it most of the time, but sometimes it cannot be avoided. So go practice the next set of homework for February the 9th and try not to use U substitution on those, so that on a test, you've got a choice. You can use it or not use it. I want you to be able to do it both ways. Then on the test, you can do your favorite whenever you want to. I'll let you pick, but there'll be some time when everybody has to use U substitution, okay? If you need some help, then I need you to email me and let me know. So use substitution, and then make sure that that formula sheet, all right, that integration formula sheet, you need to know rule 1, 2, 3, 4, and 5. You need to know rule number 7 and rule number 8. You need to know rule 13, 14, 15, and 16. We're going to go over the other ones next time on Thursday. So after Thursday, you'll know all the rules on the sheet. And so on your homework, you've got to make every homework problem fit one of these rules on this formula sheet. Okay, but you won't have the formula sheet on a test. So you've got to learn those rules on that sheet. Okay, I will see you in class on Wednesday.